All right, so this video is for 6.3 homework. We are multiplying polynomials today. So vocab, what is the name of a two-term expression? That's a binomial. So this right here, 6x plus 4, that's a binomial. There's two terms. 6x is the first term, 4 is the second term, okay? A one-term expression is a monomial. That's like if I just have a 6x, just have a 4x, just have a 2x squared, a single term. So we're going to multiply binomials. We're going to square binomials, and then we're going to do trinomials. And that's where this comes in when we get into the three pieces. This makes it way easier to keep track of everything. So polynomials or binomials, if it's both if it's two pieces, okay, you've got two options. You can FOIL this. So I'm just going to write, I'm doing this on another sheet of paper so I can do it really big. All right, 6x plus 4, x minus 5. Have y'all ever heard of FOIL? Okay. FOIL stands for first, outside, inside, last. So the first here are the first pieces in each of those binomials. We multiply those together. So we've got 6x times x. Okay. So here's how that works. If we have something that repeats like this, instead of writing it like that, there's two of them. So I can write x squared. So x times x is x squared, where kids always get messed up. X times x equals x squared. X plus x equals 2x. There's a difference. Okay? So when you're multiplying, the exponent's going up. When you're adding, the coefficient's going up. So 6x times x is 6x squared. All right, outside. Outside are the outside two parentheses, not the two that are touching, the two that are on the far side. And it's these pieces that are on the outside of those monomials. That's what the O stands for. So we've got 6x times a negative 5. Like with like. So do the numbers. 6 times negative 5 is a negative 30. There's nothing to multiply the x by, so we just keep it. It just gets tacked on. I stands for inside. So inside are those inside two parentheses, the two that touch. This one and this one. That's the inside. Okay, and we multiply those together. So we're doing 4 times x. If it's just a letter and a number that we're multiplying together, we just smush them together. 4x. And then last, L, are for the last two pieces, and that negative, it becomes a negative in this case. So don't lose a sign. So 4 times negative 5 is a negative 20. And those are the pieces when you're multiplying those numbers, and as they get bigger, that's where you may need the calculator. So we're not quite done yet. Remember, algebra is writing as few of symbols as possible. So if we have any like terms, we have an x and an x, we need to combine them. Okay, so 30x plus 4x, I just take the coefficients, negative 30 and positive 4, and I just add them together. So negative 30 plus 4 is a negative 26. Negative 26x. This has nobody to combine with, so it just stays the same. Negative 20 has nobody to combine with, so it just stays the same. If there doesn't have to happen to be a sign in front of it, like this is a negative 20, so we can make it minus 20. It would become a plus. If you're writing the whole thing together, you got to put that spacer in there. And that is my phone blowing up. Okay. So 6x squared minus 26x minus 20. That's the FOIL method. I'm going to show you another method that may work better for you. Okay. So here's another place where they trick you guys. Okay. Here's what I have a lot of kids do. They go, oh, 8x squared, and they do 8 squared is 64, x squared, and then they do 1 squared and they're done with it. That's not what this means. If we're squaring everything inside that parenthesis, that means everything inside that parenthesis is being multiplied again by itself. So you don't just square each piece, expand it out, write the whole thing out. Okay. So this is the box method. That's where this comes in. Okay. So we're doing 8x plus 1 times 8x plus 1. So on this grid paper, top left corner, mark out, we don't need it. The first vertical line, you're going to trace over it. And that top horizontal line, you're going to trace over that. Each term gets a box. So 8x plus 1. I would do 8x plus 1. So that's that first binomial. My second binomial goes vertical. Same thing. Each term, 8x, and terms are divided by plus signs or subtraction signs. That's how you know where each term is. If there's a plus sign, you're starting a new term. If there's a subtraction sign, you're starting a new term. All right, so see how we didn't put anything in these two boxes? I can mark these two columns out all the way down. I'm not going to put anything in those. Same with these two rows. I'm not going to use those. It just keeps me from getting extra pieces. So for these boxes, whatever is above it and whatever is to the left of it, you multiply together to solve this box. So 8x times 8x. Do the numbers first. 8 times 8 is 64. Then do the x's. X times x is x squared. So this box would be this 1 times this 8x. 8x times 1, anytime we multiply anything by 1, it stays itself. This box would be this 8x and this 1. So 8x times 1 is 8x. And then this box here is this 1 times this 1. 1 times 1 is 1. Cool thing about the box method, any diagonal that you have, catty corner, right? Your like terms will line up in it. So you can kind of see everything that needs to combine. So 8x plus 8x. Add the coefficients. 8 plus 8 is 16x. Nothing to combine this with. 64x squared. Nothing to combine that 1 with. So when we write it all out, 64x squared, 16x is positive, so we do plus 16x, and then the 1 is positive, so plus 1. So 64x squared plus 16x plus 1. All right, now we've got these 3-termers. The best option for the 3-termers is the paper. That's just the best option we have. It keeps everything nice and neat. And I flip mine upside down, so just so I can get everything on the screen at the same time. Okay, top left box, we mark out. Trace the first vertical line. Trace the top horizontal line. It does not matter which piece goes where. So I could put the 5x minus 7 here or here. It's not going to change your final answer. I typically just go in order. So 5x minus 7, I would do 5x in the first box, minus 7 in the second box. This one's got 3 pieces. So I'm going to start with the 2x squared. 2x squared, again, that plus sign signals I'm starting a new term. Plus 5x, subtraction signals a new term. So minus 7, I put all of it in the box, minus 7. I do that because I need to keep track of that sign, that negative. For multiplication purposes, that becomes a negative 7. Okay? So anything we don't use, any of the columns we don't use, gone. Any of the rows we don't use, Gone. Just so we don't write extra pieces in there. Okay. What's above it? What's left of it? So again, do the numbers first. 2 times 5 is 10. All right, so if x times x equaled x squared, what's x squared times x going to equal? X cubed. Okay. So when you're multiplying, it's that exponent that changes. Okay. I don't think we go any higher than that this year. It's either going to be x times x, x squared times x, or, okay, x squared times x squared. Those are those exponent rules we just did. X to the fourth. Those are the ones you'll see this year. All right, so x squared times x is x cubed. All right, this box is going to be -7 times 2x squared. So 2 times -7, -14. Nothing to multiply that x squared by. So he just kind of gets tacked on. Like with like. Do the pieces that fit together. So this one, 5x times 5x. So numbers first. 5 times 5 is 25. X times x, x squared. And if you want to write that little note to yourself somewhere in your book, go for it. All right, this box is going to be -7 times 5x. So numbers. 5 times -7 is a -35. Nobody to multiply the x by, so he just gets stuck on there. Okay, this box, 5x times -7. We just did that. So sometimes there's patterns and you don't have to do as much as you think. And then the last box here, -7 times -7 is a +49. Like terms, those diagonals. So these two have to go together. And these two have to go together. You always start with the biggest exponent when you're writing these. So my biggest exponent is that 3 there. So I know that piece is going to go first. All right, to combine these, it's just the coefficients. 25 plus -14. Combining like terms. That's all it is. But all that stuff from first semester and from like very first 6 weeks is about to start circling through. So that would be 11. 25 plus -14 is 11. And then you just keep the x squared. So this one we would do -35 plus -35. So a -70. So -70. And then that term, that x, just gets tacked on. And then the plain old number always goes at the end. But exponents will always decrease. Biggest one first. Plain old number always goes at the end. All right, so 10x cubed plus 11x squared minus 70x plus 49. All right, last one. 3 by 3. Same setup. Top left corner, gone. Vertical line, horizontal line. Oh, sorry. That is my husband checking on me. He just got they sent a reminder out that there was an ambulance here and an employee got sick. So he's like, "Are you okay?" Because the person who's going to have to need an ambulance call on him, this girl. Okay. Huh? We're doing 9. Yep. Okay. So here's my first one. 7x squared plus 6x minus 2. 7x squared plus 6x minus 2. It drives my college algebra kids nuts that I put that plus there. But I do it especially for these negatives. So I make sure that this looks just like this. I've got the right signs on everything. It's really, really easy to drop a sign, okay? The other one goes vertical. And again, it doesn't matter. I could have written this one vertically and done the 3x squared and all that across here. It doesn't change the math of it. So 3x squared plus 2x minus 7. Okay, so anything that we don't use, we get rid of. Okay, a lot of pieces here. So this box, 7x squared times 3x squared. Numbers first. 3 times 7 is 21. What did we say x squared times x squared was? X to the 4th. I will write those up on the board too. Okay. All right. And it doesn't matter what pattern you follow. So if you want to do all of these, do them in columns, fine. If you want to go and do rows first, order doesn't matter as long as you're getting each box. 6x times 3x squared. So 3 times 6 is 18. X squared times x, x cubed. Okay, this box would be negative 2 times 3x. So negative 2 times 3 is a negative 6. Nothing to multiply that x squared by, so it just gets tacked on. Okay, now 2x. 2x times 7x squared. So 7 times 2 is 14. X squared times x is x cubed. 6x times 2x. That's this box here. So 6 times 2 is 12. X times x, x squared. All right, 2x times negative 2. 2 times negative 2, negative 4. And again, if you need to use the calculator for this part of it, that's fine. You just can't do the x times x in your calculator. It's going to give you an error. Nothing to multiply the x by, so we just keep it. Okay, negative 7. So 7x squared times negative 7. So negative 49, x squared just gets tacked on. 6x times negative 7. 6 times negative 7 is a negative 42. Keep the x. Negative 2 times negative 7 is a positive 14. Okay, diagonals. These go together. They go together because they're both x cubed. Okay, they both have the same variable. And then that blue is not working very good. Okay, 21x to the 4th. That's my biggest exponent. Nobody to combine them with. All right, x cubed. I've got to combine a 14 and an 18. 32. Combining. Add them. Yep. What did I say it was? 32? Plus 32. And you just keep the x cubed. Those don't get combined when you're combining like terms. Those don't get combined. Okay. 3 numbers to combine now. So we've got negative 49 plus 12 plus negative 6. That's a negative 43, and that's an x squared. And then here, negative 42 and a negative 4. Negative 42 plus negative 4 is negative 46. That's an x piece. And then the plain old number gets tacked onto the end, the 14. They get really big, really quick multiplying. Okay, so this one would be 21x to the 4th plus 32x cubed minus 43x squared minus 46x plus 14. Okay. If you need another one of these sheets, you are more than welcome. I ran plenty of extra copies. I will put a whole nother stack of these. I will leave them up there for tomorrow because one of your pages tomorrow is multiplying. Just don't waste them. Does that make sense? Don't grab a stack like this because I won't be here to run extra copies tomorrow. Okay? Huh? I am presenting at a conference in Houston, so I'm going to teach other teachers.